Welcome to Summarize Science. Today, we're looking at a fascinating problem with modern AI. They tend to overthink. Even for simple problems, large language models can generate incredibly long and repetitive reasoning steps, which is inefficient and costly. This paper introduces a clever way to fix that. Just look at this example from the paper. The original AI model is asked a straightforward math problem. It finds the correct answer, 18, pretty early on. But then it spends hundreds of extra words second-guessing itself with phrases like, wait, let me check again, and seems straightforward. Wait, but... In contrast, the researcher's newly trained model finds the answer, does one quick confirmation, and provides the final result, cutting the length by over 60%. So how did they teach the AI to be more concise? First, they needed a way to measure overthinking. They introduced a metric called Token Entropy Cumulative Average, or TECA. In simple terms, entropy measures the AI's uncertainty at each step. TECA tracks the average uncertainty throughout the entire thought process. These graphs show the TECA score during a task. For efficient models, the uncertainty rises briefly as they explore options, and then it drops as they lock in an answer. But for the overthinking model, the uncertainty just keeps rising, showing it never becomes confident and just keeps exploring needlessly. Armed with this metric, they proposed a new training philosophy: explore briefly, then decide. The idea is to mimic efficient human reasoning. We brainstorm for a bit, but then we make a decision. They implemented this using a clever reward system. During training, the AI gets rewarded not only for getting the answer right, but also for having a low TECA score at the end. This encourages the model to find a correct path and then confidently stick with it. The results speak for themselves. As you can see in this table, their method, called CR, drastically reduced the length of the AI's responses across multiple datasets. On simpler math problems, the response length was cut by up to 71% with no loss in accuracy. Crucially, the method is adaptive. On more complex problems, the AI still takes its time, but it cuts out the unnecessary steps on easier tasks. This case study really highlights the difference. The original model reflects on its answer 6 different times, while the new model reflects only once before confirming its correct answer. It learned to be confident and efficient. So, let's recap the important points. AI overthinking is a real problem that wastes computational resources. The researchers created a metric, TECA, to measure this inefficiency and then used it to train models with a new explore briefly, then decide approach. This resulted in AIs that are just as smart, but much faster and more concise. In the future, this could lead to AI assistants that are more responsive and cheaper to run, making them more practical for everyone. Thanks for watching Summarize Science.